Good morning or good afternoon, depending on where you are. Thanks for taking time to join us on our webinar today, which is on the importance of provisioning in Compliant Database DevOps. So what I've found from my conversations with different folks from different organizations is that just like DevOps, the term provisioning can also mean different things depending on who you talk to. So don't worry if you're still confused about the topic of this webinar. I promise you that by the end of the webinar today, you'll have a clear idea of what we mean by provisioning, as well as what we mean by database DevOps. So a couple of housekeeping items before we get started. Everyone will be on mute throughout the webinar, but we want to hear your question. So if you have any, please post them in the questions box on the GoToWebinar panel, and I'll try my best to answer as many of them as possible at the end of our webinar. This webinar is also being recorded, and the recording will be available on our website, hopefully sometime next week. My name is Arneh Eskandari, and I've been with Redgate for almost 8 years now. I'm currently leading our sales engineering team here in the US, and as part of my role, I work with hundreds of organizations in their journey towards DevOps and have helped them improve their SQL Server database change management process and streamline it with their practices on the application code side. So I'm quite familiar with the challenges that DB shops run into when it comes to speeding up development and delivery processes. So here's my contact details, so feel free to reach out if you have any questions or even any comments or feedback post our webinar today. So a little about Redgate for those of you who are new to us. So we specialize in helping IT shops improve their database change management and delivery practices and be able to incorporate their databases into their bigger DevOps initiatives. We've been in the business for 19 years now, and just like any 19-year-old, we're still growing and developing and trying to find new ways to address common problems faced by database professionals. We have over 200,000 customers from 91% of Fortune 100 to startups and everything in between. And most importantly, the main thing that I'd like to draw your attention to is that as a software company, we eat our own dog food. And as a result, we've been able to release more than 582 times so far this year, which is a number that seems to be growing year on year. Now, let's start off by talking about database DevOps. A lot of you might already be familiar with this diagram here from past webinars or Redgate white papers. This is how we've been envisaging database DevOps until now. Which is all about aligning database change management with best practices that we might have in place for application code, such as source controlling in development and creating audit trails and logs of who's made what change, when, and why, identifying and fixing issues as soon as they're introduced in dev through automated builds and tests in a CI pipeline, and delivering good quality code as a result up the chain all the way to production through a standardized release management process. However, this process is incomplete when it comes to databases. With databases, we also need to think about the process of creating and refreshing the physical copies of databases that are being used for development and testing purposes. So that means the data travels back to the lower environment. So we need to think about securing any sensitive data that gets copied down to those environments from production. Speaking of securing data, so as we're required to innovate faster, it is also more important than ever that the right data governance processes and security measures are in place to help us avoid data misuse and meet data protection regulations. Despite understanding the devastation a data breach can cause for you and your customers, data breaches are on the rise, regardless of what industry or your sector you're in. The headlines you see here on the screen are just a small snippet, most of which are from the past couple of months. A recent example was, for example, the T-Mobile data breach where personal information of more than 2 million customers were stolen. Another good example was Facebook, where accounts of more than 50 million users were exposed. So these are just two examples of recent data breaches, but a harsh reminder of how quickly a data breach can change the course of an organization, taking away from goals such as customer retention, revenue growth, and innovation. And obviously, the more time you spend fixing errors, responding to a breach, the less time you spend innovating and delivering value to your customers. With this rising tide of data breaches, of course, we are now faced with more data protection regulations than ever that have introduced strict laws, hefty penalties, and even possible prison sentences. For example, with HIPAA, penalties can be as much as $1.5 million and 10 years in prison, or SOX compliance with up to $5 million in fines and 20 years in prison. And what that really means is that we can no longer shy away from the responsibility of protecting our business critical and sensitive data. And of course, this brings with it the new challenges of how we can protect the data without negatively impacting our existing processes or introducing new bottlenecks. In a recent research we conducted at Redgate, we wanted to identify how organizations currently provision databases and to assess the importance of provisioning requirements to ensure adherence to these emerging data protection obligations that we just saw on the previous slide. We gathered responses from nearly 500 data professionals from a wide range of job roles and from a variety of industries. You can see one of the findings on the screen now. So software teams want to use production data. This is no surprise. It's just more predictable and reliable, but it's also not compliant. Given this need for production data, the stats on this slide may not come as a surprise either, but the numbers are quite shocking. So as you can see, 72% of our respondents use a direct copy of production in their development, test, and QA environment. Of course, this can help us test the production readiness of our changes in development, but puts our sensitive data and our organization at risk. This is also something that was discussed in the 5th episode of our DBAL podcast that is hosted by a couple of my colleagues here, both named Chris. So the 5th episode that got aired a couple of days ago was themed around Halloween, and they talked about the top 10 horrors of SQL Server. And unsurprisingly, one of the top 10 items was provisioning databases for dev and test purposes by restoring backups of production databases. The reason why this is scary is quite obvious, because you're increasing the surface area for an attack by duplicating your sensitive data and making your non-prod environments an easy target for the hackers. Oh, and by the way, don't forget to check out DBL. I guarantee that you'll enjoy listening to Chris and Chris. So based on everything we talked about so far, here's our new preferred diagram for Compliant Database DevOps. By introducing the bottom section, we are emphasizing that data travels backwards as well as forwards. We cannot deliver value to our customers and end users without first understanding the impact of these changes on real data and by just developing against empty databases, right? So DevOps for database obviously helps with compliance by standardizing team-based development that we talked about, such as source controlling, standardizing the way people write SQL, and so on and so forth, as well as automating builds and deployments and monitoring performance and availability. But we're still missing ensuring secure distribution of data. And that's why we have this new diagram here, where backup and provisioning are now included to create that cyclical process. So backing up our data to ensure we can preserve the data, and hopefully all of you out there are already doing this, and provisioning and masking sensitive data to ensure the protection of our data in non-production environments, which is what we are going to focus on as part of our demo today in this webinar. So quickly, to go over the what we mean exactly by provisioning and what provisioning means in Redgate's offering. So it's all about replacing sensitive data with realistic looking data. So masking your sensitive data and provisioning them down to lower environments for development and testing. Creating SQL Server database copies in an instant. So with the need to innovate faster and deliver, changes in code faster, we can no longer afford to wait for long restore processes of backups, especially if we're dealing with really large databases. So we need to find ways to speed up that process and make it a non-event, and allow our developers and testers to refresh their environments as frequently as they want and as quickly as they want. As part of that, obviously, comes this saving aspect of the process. So by virtualizing isolated environments, we allow you to save a ton of disk space and be able to spin up databases on whatever SQL Server instance that you want without having to worry about, the the disk space or storage limitations. So obviously, it's a very common practice for us, for example, to be working against a shared development or testing database because, again, of the size restrictions. We normally deal with a lot of data and we deal with large databases, so it just doesn't make sense to spin up really large databases for each individual developer because it obviously takes a lot of time. It's a lot of headache for DBAs and operations people, and it just needs a lot of disk space. So by virtualizing, we actually allow you to do that by removing the constraints on, storage, time that it takes to spin up databases, and so on. And finally, pseudonymizing data for development and testing purposes as part of the masking process. Automating that whole process with your DevOps initiative, and finally providing a central auditable view of your database copies so you can see what database copies exist in your non-production environment, who's spun up what database where, and what kind of activities were performed against your databases in those environments. So without further ado, let's go ahead and take a look at the demo here. So let me stop the presentation first. Okay, so our provisioning solution basically consists of two main components. So one is the SQL clone, or our cloning technology that allows you to create virtualized copies of the databases that we just talked about. And the second component is the masking, which allows you to mask your sensitive data and provision it down to your lower environments for development and testing. What we're looking here is the SQL clone dashboard. So this is where you can see basically all your clones in the databases that you've spun up in different environments using SQL clone, as well as the images that your clones are created from. So this is just like virtual machines. So you create an image of a database, and then you can then start creating clones of that database from the image. So we rely heavily on disk virtualization technology from Windows and Microsoft to be able to do this. So we'll go into details on how that's exactly done. But before I do that, I quickly want to show you the workflow of creating a clone. Right. So here I have an image of the Stack Overflow database. And the database is at 100 gigabytes, as you can see. And I already have 10 clones of this image. And you can see here the sizes of those clones are just in tens of megabytes as opposed to 100 gigabyte. So again, this is what the disk virtualization allows us to do to help us save disk space and spin up clones instantaneously. So let's try and create one. So I'm going to skip any modifications to the clone. Specify the SQL Server instance where I want the clone to get spun up on. And I'm going to give my clone a name. So let's call this Stack Overflow Provision Webinar. All right, as you can see, my clone is being created, and it only took a couple of seconds to create a copy of a 100 gig database on my laptop here. So let's go ahead and take a look at that database real quick. All right, so here's a database that I just created. Now, as far as SQL Server is concerned, it cannot tell the difference between a normal database and a clone database. So even though this is only taking up, let's see how much it's taking up on our disk here. Even though this is only taking up 78 megabytes on disk, but SQL Server sees this as a full database. So if you go to my properties of my database, you can see that this is a full 110 gigabyte database. But on my local disk, it's only taking up 78 megabytes. So how do we do that? Right, so we have a good architectural diagram that I normally like to share with our customers. So, and that is presented here. So this basically is the architecture of how SQL clone works. So what you're seeing here in the middle at the top is the server where you install SQL clone. So there's a web server and obviously the dashboard that runs from that server. And then on top of that, at the bottom, there is a network share where you would be storing your images that you create from your databases. So the process of cloning a database starts off by creating an image. So here on the right side, this server represents basically a production environment or some databases that we want to create clones from. So here we have a 1 terabyte database, and the first step is to create an image of that 1 terabyte database, which basically what it does is that it creates a virtual hard disk and then saves off the MDF file and the LDF files or your data files on that virtual hard disk. So once the image is created and sits on the network share, then from there, you can go ahead and spin up any clones, as many clones as you want off of that single image. So the clone basically is just a virtual hard disk mount pointing to the image location. That's why it needs to be on a network share. And there is also a differencing disk that is a secondary virtual hard disk where we store any changes that you make to those clones, either whether it's data changes or schema changes, doesn't matter. And this differencing disk is what allows each clone to, to perform independently of any other clones or the image itself. So any changes you make to a clone will not affect the image or any other clones that are spawned up from that image, because each clone has its own differencing disk where the changes are stored. And essentially the size of your clone locally is basically the size of that differencing disk, because the virtual hard disk mount doesn't really take up any space on your machine. It's just mounting to a virtual hard disk on a secondary location, which happens to be the file share where our images are stored. So this is basically the architecture and the process for how SQL clone works. So what I'd like to do next here is kind of walk through the process of how data masking fits into this process, right? So this is great. So far we've talked about the virtualization aspect of it and how we can allow you to spin up virtualized copies of your database. But the question that we haven't answered yet is then how do you protect sensitive data as part of this process? When you're creating your image, you're still bringing full data from production to that image. So where does the data masking fit into this? So let's go ahead and talk about that. So I want to kind of start from scratch of creating an image of a source database, mask that data in the database, and then making those images available for cloning using SQL Clone. So here I have a database called DM Database. So this database, let's quickly take a look at the structure. So we've got some tables. Obviously, as you can see, some sensitive data based on the table name. So customer, for example, contains first names, last names, addresses, credit card numbers, and so on, phone numbers. So a lot of PII here that we need to mask before we provision those down to lower environments for development and testing purposes. So to do that, as I said, we have the second component in our provision, which is the data masker. So I'm going to go ahead and launch data masker here. The way that data masker works is that you define masking rules for different tables and columns that hold sensitive data, and then you can save those masking rules as a masking set and run that set either manually against any given database or run it automatically as part of an image creation process in Clone before you can start spinning up clones from those images. So here I have an empty masking set. So I'm going to start off by building some masking rules against that DM database and the customer table, for example, to start with. And then we'll then save this off and see how this can be run as part of the image creation process in Clone. So let's get started. So let's go ahead and create a new masking set here. So we need to point it to a database. So let me just copy my server name here. Okay, and we want to point this to the database. specify our SQL Server instance or the version. So we create a couple of tables for audit purposes, so keeping track of, how many records have been masked, what rules have ran, and so on. So it gives you a good audit trail of, the masking that you've done on the specific databases. Right. So gathering the database structure information such as tables, indexes, triggers, foreign keys, etc. All right, now we've got our tables. Let's also get the record count for each table. And we can now go ahead and start creating our masking set. So here, notice the masking process automatically added a couple of rules here. So each row here represents a single rule. So there are different types of rules that we'll take a look at in a little bit that you can apply in a masking set depending on what kind of data you have and how you want to go about masking it. But these two rules are always added automatically. So it's, as you can see, it's trigger manager. So the first one is disabling. The second one is enabling triggers. So if you have any update triggers, obviously you don't want those to get triggered as we are masking the data, because our masking process is static data masking, which means that we are actually replacing the data in the target database that you point this masking set to. And we typically do that by running a bunch of DML scripts and update scripts in the background or SQL scripts in order to replace your real data with realistic test data. So if there is any triggers, obviously those are going to go off if we run any update scripts as part of our masking process. So we're disabling those to prevent any performance issues or slowness in our masking process. So let's go ahead and start adding our masking rules. So as you can see, there's different types of rules available. So we'll go over a couple of those, the most common ones that we see our customers using. One of the common ones is substitution rules, where you're simply substituting your real data or common, PII and PHI information with some realistic test data that are provided as part of the data masker tool. So for example, first name and last names are good ones. So I can just simply replace the real ones with some test ones that are provided by the data masker. So if I go here and look at my names, so I'm going to do some names, first names, male. The reason why I want this to be gender specific is because we also have a column called customer gender that keeps track of gender. So obviously we might have males, females, and also people who decided not to provide that information, so a bunch of nulls under that column. So the way I'm going to go about masking this is I will assign a male name to all of the records in the table, regardless of their gender, and then I'll apply a secondary masking to first name to then mask the existing records and replace them with a female name where the customer gender is female. So let's go ahead and do that. So I'm just going to replace these with some first names for males to start with. So I got my substitution rule created. I'm going to create another one here to now take care of the females and replace those male names that we just populated with female names for those who have a customer gender of female or F. So again, we're doing this against first name. So go find first names for female. First name's female. Now, in order to do this, we need to run a where clause, right? So to specify the where, the filter rule. So we want this to only be applied to customers where customer gender is female. All right, so now we have our two substitution rules just for first name. So the first one, again, just replaces everything with male names. The second one replaces those names to female names if the gender is F. So now Another great thing about Data Masker is that it allows you to run your masking set in a multi-threaded fashion. So if you look at our run statistics tab here, we can see that you can provide multiple workers. So if you say one worker, that will be a single thread. If you define more than one, then it will be multi-threaded. Now, when you do a multi-threaded session, it's really important to kind of think about the order of the rules and how you want them to run. Because when you do it in multi-threaded fashion, that means you can run multiple rules concurrently in order to speed up the process. But in some cases, some rules are dependent on other rules. Like in this case, the second rule for replacing the names with female names relies on the first substitution rule to complete, right? So we cannot run these two concurrently. So what I'm going to do is I'm going to make this a dependency on the first rule here. So this way we're telling Data Masker that if you're running multiple workers, make sure that this task or this rule is complete before you go on to XX0005. All right, so now I'm going to go ahead and add some additional rules here to take care of, the last name and a couple of other sensitive columns here. So let's go ahead and select our last name here and replace that with some last names. So let's do some random surnames. And we can also sample our data if you want to see what kind of data will be populated if you go with this data set. So you can take a look at some samples here. All right, let's go ahead and create that. All right, so now we just created some substitution rules. We can continue doing this for, address, telephone number, credit card number, but I'm not going to do that for the sake of time here. However, there is a couple of other columns that we cannot just mask by substitution. So for instance, email, right? So customer email normally has either first, last name, or some PII from the customer in the email, right? So if you're going with first last name, then obviously when you mask the first and last name, you want that email to still be relevant, right? So, and we cannot just say substitute, because substitute will just generate some random email addresses without any relation to the first and last name of the given record that you're looking at. So in order to do that properly, I can introduce another type of a rule called a row internal sync rule, which just basically allows me to, provide rules of how I want a certain column to be masked based on value from other columns within a given record. So for instance, here I can run this SQL here to simply take the customer first name and the customer last name and do at dmtest.com or something like that. And this is going to take the masked first name, masked last name, and create the email address for us. So I'm going to do that here, provide the SQL for it. And this is going to be used for the email column. So let's go ahead and select the email column. And that's it. So that's how we want to take care of the email address here. Go ahead and create that rule. And email is obviously another rule here that relies on the first and last name, right? So we have to wait for first and last name to be generated before we can then generate the email address. So in this case, I'm just doing a single thread because it's a small database, so it doesn't matter. I can just do everything sequentially, but I could just make this a dependency on the previous rules as well. And one final thing, so in this database, we have another table called customer nodes that actually holds some data from the customer table. So so customer first name and last name are basically, this should be the same as what's in the customer table. So it's very common for us to want to, first of all, it's very common for us to have denormalized data like this in our databases, and also, be able to mask the data that duplicate data between tables successfully. So whatever data we replace the customer table with, we want to make sure that the first name, last names in customer nodes match that. So to do that, I can create a table-to-table sync rule, for example, to define what columns I want to keep in sync between different tables as part of this masking process. So I'm going to go ahead and create this rule here. So the way it works is you specify two tables where you want the data to get synced. So again, it's DM customer on the left side and DM customer notes on the right side. And then we specify which columns within these tables we want to sync. So first name from left to first name on right, and last name from left to last name on right. And obviously to do that successfully, we need a join condition. So we're going to do the join based on customer ID from both tables. All right, and that's all we need. So I can go ahead and create this table to table rule here. All right, so I can just continue building rules for all the sensitive data in this database, but obviously we only have an hour, so I'm just gonna leave it at this and create my masking set. So I could just go ahead and run this masking set against the database that we just created off of, which is what's defined here in the controller. I can also save this as a masking set. So I'm gonna call this DM database, for example. Okay. And I'm going to use this masking set in my image creation process in SQL Clone. So let's take a look at what that process looks like here. So I'm going to start up by creating an image. So you can create an image off of a backup of a source database or production database. And that can be a full backup or differential backups, or you can create it directly by pointing to a SQL Server database. So in this case, I'm just going to point it to my DM database that we looked at. So here it's asking me if I want to make any modifications to the image. So a modification is basically, getting rid of any production specific permissions, users, or, masking sensitive data. So anything that is production specific that you don't want to, copy down to your lower environments can be scrubbed or replaced by either running a bunch of SQL scripts that you can provide or applying a masking set, such as the one that we just created. So I'm going to go ahead and find that masking set that we just created for DM database. And I'm going to apply this as part of the image creation process. So when my image is created, the sensitive data that we define in those rules will be automatically masked. So any clones that we spin up of that image will also have the sensitive data masked as a result. So specify the network share where I want this image to be created on. So let's give our image a name. So I'm going to call this DM database webinar. So as you can see here, my image is now being created. So again, this is basically mounting the data files to a temporary database and then applying the masking set to that. And then once it's done, then it copies the MDF and LDF files to a virtual hard disk on the network share. So as you can see, our image got created successfully here. So what that means is I can now go ahead and spin up clones off of that image wherever I want. So let's go ahead and take a look at that image in our dashboard. Here it is. We just created it. So there's currently no clones off of this image, so I'm just going to create a new one here. And I'm just going to put it on my laptop again. So let's call this DM database Arneh. All right, so my clone is getting created here. All right, now let's go ahead and take a look at it. All right, let's refresh my databases. We should have a database called DM database underscore Arneh now. Here we are. And again, this is basically represented as a full database, as we saw earlier on. So what I would like to do here is to now actually compare the data between the clone that we just created and the actual database where we created the image from. So let's go ahead and take a look at that. So let's look at the data in the actual database to begin with first. So let's look at the data in our customer table in the source database. Here it is. And let's just create a vertical tab here. Okay, so we're now going to do the same thing with the clone that we just created and take a look at the data in the customer table in our clone. So as you can see here, what we're looking at on the left side is the real data, and what we're looking on the right side is the test data or the mass data that we just created. So you can see the first name, last name are now different from the real ones, and so is email, which is basically looks pretty real. It's off of the mass first and last name. So here I've got Fraser, and the customer email matches that as well. So the good thing about this is that, as you can see now, any clones that you spin up from a masked image will also contain masked data. So this is, you no longer need to manually, as a DBA or an operations person, make sure that any clones that are spawned up, have masked data. As long as the image is masked, then any clones that you spin up from that image are masked. So it puts you at ease as an operations person. It gives you the ability to provide more freedom to your developers and DBAs to go in and create their clones off of the dashboard, so you can provide, for example, different types of permissions. You can give clone only permissions, so people can just go ahead and create clones off of the images that you have provided. And the good thing about this is that you can keep an audit trail and log off exactly who does what on SQL Clone. Whether it's creating new clones. If it is, you can see, what SQL Server instance it got created, what the name of the clone was, who created it, take a look at the logs. And even if someone deletes something, like here you can see what deleted a bunch of, clones, for example, previously, I can also see those. And I can see also who deleted those. So I get the name of people who have performed some activities on the SQL Clone dashboard. The other thing I wanted to quickly show you here is the customer nodes table, right? So we applied a table-to-table sync rule to synchronize the mass data across the customer table and customer nodes for first and last name. So let's look at the data in this table now on the mass version. So here we can see, for example, the first customer is Filiberto Simpson, right, with this specific customer ID. So if I look up this customer ID on the customer table, I should see the same person there. So let's go ahead and copy that and take a look at the customer table, where customer ID equals to that. And as you can see on the customer table, it returned the same customer with the customer ID of that. So this is basically shows that of course the table-to-table sync rule works and how easy it is to do that. Okay, perfect. So just to quickly recap the things that we've talked about from the the slide where we talked about what our provisioning offers. So we looked at how we can replace sensitive data with realistic looking data by creating masking rules and creating masking sets, and either run those masking sets manually against a given database or run them as part of an image creation, so that way any clones that you spin up from those images will have the data masked automatically. We also looked at how you can create SQL Server database copies in an instant within a matter of seconds, regardless of what the size of your database is, and also the disk space saving aspect of it, again, regardless of what your size of your database is. Now, we also looked at the central auditable view of the database copies through the dashboard. So kind of going back to the activities that we just saw and see exactly where your images are through the dashboard, so you can see what images reside on what network share. You can also look at your clones by instance, so you can see what SQL Server instances have clones on them, and then kind of dig into them and see exactly what clones, who created them, and so on, and when. So the only thing that is left is the automation of this process with DevOps, right? So everything we did so far was manual. We had to go into the dashboard to create clones, create images, but this whole process can also be automated through PowerShell. So if you look at our settings here, you can see there is PowerShell commandlets that you can download in order to either, let's say if you want to automatically refresh your images on a specific frequency, so you can, or schedule, then you can run the PowerShell from, task scheduler or whatever automated process without you having to be there as a person or interact with the dashboard to create your images. Same comes to, creating clones or refreshing clones or dropping clones and things like that. So you have access to PowerShell too for automation purposes. Just to show you a quick example of how this can tie into a DevOps approach. So we talked about kind of how you can spin up databases for development and testing purposes, allow your developers to move away from shared development databases and have their own dedicated databases, and be able to quickly spin up their databases, make changes, refresh their databases, and so on. And then kind of go from there. So we've talked about that aspect of provisioning and speeding up the provisioning process for development and testing process. But this can also be used in an automated fashion specifically for automated testing, for example, or automated deployments to copies of production. So for instance, here in my Visual Studio, or my Azure DevOps pipeline, my continuous integration process, as you can see, I have a bunch of tasks that are run for my database, starting off with Redgate SQL Change Automation Build, which is basically building my database from my database project. But I also have some additional tasks here, specifically from SQL Clone, that allows me to create a clone automatically as part of the build process of a production image. And then I do a test deployment against that clone to make sure that I can successfully deploy the database project that we just checked out and built from source control against a true copy of production that has the same amount of data on it. And then if everything goes well, then I just delete the clone at the end. So this kind of goes back to the aspect of shifting things left, something that we hear a lot when it comes to database DevOps or just DevOps in general. So here we kind of shift left the process of testing the production readiness of our changes into the build process. So before we were even ready to release out to any of our higher environments, we are testing the deployment against production copy by utilizing the cloning technology. So one more thing that I wanted to also touch on before we wrap up the demo. So going back to kind of the use case for development and testing process, I mentioned that this allows your developers to easily spin up clones and even refresh their clones within just a matter of seconds. So let's say as a developer, if I make a mistake, so let me just delete a column, right, to demonstrate that on my clone database. So I just deleted the column, which means I also lost all the data in that column, but that was a mistake, so I need to bring it back. I can just simply go into SQL Clone here and go to my clone that I just spun up And I can just say reset my clone. And what this does is that it resets the clone to match the original state of the image that it got created from. So this should take a couple of seconds. As you can see, my clone got reset successfully. So if I refresh my tables again on this database, I should see the customer notes table back in there. And as you see, it's instantaneous, and it doesn't matter how large your database is. Normally, DBAs find themselves spending a lot of time, refreshing databases for lower environments for development and testers. And if it's something that needs to be done on an ad hoc, basis, either because the developers kind of stepped on each other's toes in a shared environment or broke the database, and now they want a fresh copy of production, then that's going to take some time if you're just doing a normal backup and restore. So having this capability here allows you to quickly and effectively and efficiently refresh your lower environments without having to go through a full backup and restore process. So that concludes our demo. Now let me go back to our slides here. So before we go, I'd like to quickly highlight one more thing here. So the Gartner report that you see on this slide. So we talked quite a bit about the importance of masking your data in today's session to desensitize and protect business critical data. So if you found that interesting, we believe you might also appreciate this. So Gartner recently published their 2018 Market Guide for Data Masking report. In this report, they recommend that data masking products should provide tools to manage the full lifecycle of masking data, such as deploy masking rules, schedule or trigger a masking job, and monitor the performance of static data masking or dynamic data masking operations. And Redgate is acknowledged in the guide as a representative vendor for data masking. So if you visit the website on the screen here, you can get your, redgate.com/Gartner. You can get your complimentary report from there. And this is only available for limited time, so be sure to get your own copy now. Thanks again, everyone, for your time today, and I hope you all have a wonderful rest of the day. Thank you.